So thank you for coming to my talk called Laying the Cultural and Technical Foundation for Big Rails. Just to start off, I wanted to take a moment to thank everyone who's helped contribute and maintain Rails. They all created something bigger than themselves and inspired people and businesses of all sizes, so thank you to them. And also thank you to everyone who helped put together this conference and brought us here today. So a little bit about me. My name is Alex. I'm really happy to be here today and to speak with you all. I appreciate you taking the time to come. So I'm from, I live with my partner in Vermont, and I enjoyed lots of crunchy things like gardening. This is a picture of our work-in-progress garden. And enjoy, crunchy things like eating fresh fruits and vegetables and compost and stuff like that. I've worked at Gusto for the past almost 6 years now, and I work there on the product infrastructure team, working mostly on back-end modularization. And before that, I worked on the benefits team. I really love working at Gusto, and I'll be available all conference and beyond if you want to learn more. So to dive in, this here was Gusto's system graph. Each of the black rectangles you see is a subsystem within Gusto's biggest Rails monolith, and the red arrows are when one subsystem talks to another. Over time, despite our team growing at a linear or even exponential rate, we noticed our per contributor velocity actually decreasing over time. It became harder to add new features, and we often found that implementing a new feature made the next feature harder rather than easier. We noticed people were having a hard time making large-scale changes in our code base, because to make large-scale changes, you needed to have structure at scale, which we didn't have. So how do we even begin to solve this problem? And we tried a couple of things. We tried by creating gems and Rails engines. In the better cases, we found that our business logic was so entangled that the best we could do was extract small and mostly functional components that in some cases didn't have the most business value without making too much of a dent in the larger complexity of our application. In the worst cases, it sent us on a bit of a wild goose chase. We knew we had many years of work ahead if we wanted to extract all of our code into gems and engines. We also tried microservices for new and existing services and have had varying degrees of success. But all these techniques were no match for our ever-growing Rails monoliths. So this is all a story of how Gusto's complexity grew and brought me here today to share this story with you. In this story, I'll talk a little bit about some of the progress we've made, and I'll share some tools and techniques that have helped us. As I share this story, keep in mind that I've taken some creative liberty to tell the story in a way that I hope will help you avoid making some of the mistakes that we made along the way, but I'd be happy to share some of those mistakes if you're curious. So Gusto first began as a payroll provider for small businesses in California. Over the years, we grew in the geography we serve and the problems we solve, and today we help companies run payroll, get their taxes right, set up health insurance benefits, take care of their employees, and a lot more. Gusto has a lot lower web traffic and data storage requirements compared to a lot of similar companies. If we do our job right, users are spending very little time on our website running payroll or figuring out how to set up their health insurance benefits. And my personal opinion is that the less time that they have to spend on our site and the less data that we can hold about our customers, the better. So that's why this story is not about performance or big data or web traffic throughput, but instead about scaling domain complexity. If this story feels familiar to you, you may be working in a big Rails application too. We want to change something about this story, and we can. So big Rails. Lots of people have different definitions for big Rails. One definition here is that big Rails is a system of socio-technical tools practices, and conventions that scale Rails development in terms of lifespan, number of contributors, and complexity. Some of these 5 key principles that I want to share that have driven a lot of our approach to big Rails are accountability and ownership, clear boundaries, thoughtful dependency management, gradual adoption, intentionally curated and sustainable feedback loops. So accountability and ownership. So imagine this code exists in your code base. When this code is called, who receives the error? How do you route the error to the right team? Who do you ask about making a change to this code when git blame shows dozens of people who have changed teams or left the company? Accountability and ownership is all about striving to make it clear what team is responsible for what behavioral and structural concerns of the code base. We want it to be possible to identify ownership by both human operators working within the code base as well as automated tooling. For example, an engineer should be able to follow familiar and simple practices to identify what team owns a part of the domain. Bugs, logs, monitoring, asynchronous processes, and more should be attributable to a specific team. To accomplish this, we created 2 gems, code ownership and teams. We've open sourced these in advance of this talk, along with several other tools that I'll be talking about. Keep an eye out for that Ruby Gems logo on the bottom right to see references to open source gems. And also, you can find all the references I'll talk about in the Gusto engineering blog. On the left, you can see a basic team declaration, and on the right shows how code ownership can be used to tie that original piece of code back to the team. With this, we could suddenly tie our code base to specific teams and people. Our error monitoring system tagged bugs with individual teams, so teams could be responsible for their own impact on system behavior, and could also set their own SLAs and tolerance for errors based on their own business objectives. We configured our asynchronous work system, Sidekick, to tag jobs with owner information, so Datadog dashboards could be filtered by team. We also use this to generate our GitHub code owners file programmatically, so teams would receive notifications to review code correctly. As an added bonus, this also started conversations about code ownership, or lack thereof, throughout our code base for new and existing code. This pushed us towards the need to create boundaries, as it's tough to have boundaries without accountability and ownership. So having clear boundaries is about working towards easily understandable, conceptual, and mechanical separation between domains. Each system should only ever talk to other systems via intentionally maintained public API. Thoughtful dependency management is about attempting to minimize dependencies to help reduce cognitive load to understand a system. When we must take on a dependency, we should do so explicitly. We should avoid creating cycles in our dependency graph, as they reduce our ability to understand a subsystem in isolation. To move towards this goal, we started with one simple change to a standard Rails convention. Here you see your standard Rails app. It has an app directory, and then secondary directories for architectural concerns like models, views, controllers, services, followed by directories for the business domains. So I mentioned earlier, I was on the benefits team for a long time. That meant that as a product engineer on that team, I'd have to jump across folders to work in my team's part of the code base. Not only did this feel wrong, but it violated an important principle of coupling and cohesion, namely things that change together should live together. What we really, really wanted was for all of the benefit stuff to be in the same folder. So that's what we did. We felt it was a lot less meaningful to divide up the app by architectural layer and a lot more meaningful to divide it up by domain. Note that we didn't divide it up by team, as our software shouldn't model our organizational structure. This move didn't require a ton of extra technology out of the gate besides setting up some load paths, but we made that easy by creating and open sourcing a gem called Stimpack. Once you add it to your gem file, it sets up Rails load paths and more for this structure. Keep in mind that this switch is well supported by Rails if you want to configure it yourself as well. In fact, this is really similar to Rails engines, but we didn't use Rails engines for this for some important reasons I'll talk about later. This pattern also came with a lot of other nice benefits, such as test files being co-located alongside the code they tested, and the technologies that domain used being more of an implementation detail that's hidden from consumers. Note that I don't mean to imply that the Rails default way of organizing by architectural layer is wrong. Instead, most new Rails projects tend to cover a single domain, so the pattern on the left makes a lot of sense for those apps. So now that we had our app divided up on the basis of domain, the next question was, how can we systematically manage the relationship between those domains? This is where Packwork comes in. I wanted to thank Shopify for this wonderful tool that has provided us with such cool opportunities. With Packwork, we kept the structure that we had before, where we organized first by domain, and then we dropped in this package YAML file that you can see there on the right. Note that Packwork doesn't care how your file system is organized, but we found it really, really helpful when our system was organized by domain first. We also added an owner field in the package YAML, which is a custom field that Gusto added that's used by the code ownership gem. Next up, we added public folders to each package. This holds our public API with everything else being private. Now I'll talk about how Packwork works. So your basic building block for Packwork is a package. At Gusto, we often call this a pack, mostly because it's shorter to write and say. And we use the terms pack and package interchangeably. A pack is simply any folder of code that has a package.yaml at its root, which are the nodes in this graph. Note that each node has an inner concentric circle, which represents the private API, and the outer ring being the public boundary that the pack exposes to the outside world. Packwork offers several ways to declare something to be public or private, but at Gusto, we stick with having a public folder because we really like the idea that the default mode is that everything is private. So I've added 2 other systems, and now we have 3 packs. We have benefits, HR, and payroll. In the package YAML of each pack, there are a list of dependencies on the other packs, which I've drawn as these large white arrows. Packwork requires that these explicitly stated dependencies never form a cycle, which is one of my favorite features of Packwork. In this small system, the HR pack depends on benefits and payroll, the benefits pack depends on payroll, and the payroll pack depends on neither. Next, Packwork will parse every Ruby, ERB, and rake file using the same parser that Rubocop uses. After parsing the file, it will hold on to a list of every constant class or module that is referenced within the code of that pack. These references are denoted here as purple squares. 2 notes about this process. First, Packwork relies on the static analysis of the code base to do this. This means that Packwork is not needed in production at all, nor is it loaded during runtime. Secondly, this means that implicit references to constant classes or modules may be hidden from Packwork, and we really like using the Ruby static type checker sorbet to give Packwork more to work with. After Packwork parses the files, it draws edges between a reference to a class, constant, or module, the purple squares, and its definition, which I represent as an orange circle. Packwork knows where something is defined because Zeitwerk, the autoloader for Rails, establishes a convention that Packwork leans on, hence the name Packwork. Note that these arrows may not respect the public API of the other package. Similarly, a pack may use a class from another package without stating a dependency. Packwork represents these deviations from our desired use of API and dependencies as something they call dependency and privacy violations. So I'll talk about these dotted red arrows in a second, but notice the solid green arrow on the bottom right. Packwork doesn't detect a problem here because the HR pack is referencing public API from the payroll pack, and it has declared a dependency on payroll. So let's talk about those dotted red arrows. Let's focus on that topmost violation. So this reference from benefits to HR is both a privacy and a dependency violation, which is why the line is doubled. This is a privacy violation because the benefits pack is making a reference to a class, constant, or module from the HR pack that is private to HR. At Gusto, this means that it's accessing something that isn't defined in the public folder of the other pack. This is a dependency violation because the benefits pack is using HR without having listed HR as a dependency. Dependency violations can occur even if benefits were using the public API. All of this is important because clear boundaries and thoughtful dependency management are cornerstones of managing a big Rails application. And Packwork makes these principles much easier to follow. So this code snippet on the bottom left shows a little bit of example code that would result in the relationship in the Packwork graph. In this case, HR helper is private API of the HR pack, and benefits does not list the dependency on HR. Packwork constructs this graph and outputs these red dotted arrows as what is basically a to-do list of violations shown on the bottom right. I cannot emphasize enough how important and impactful having this to-do list is to allow us to improve our system gradually over time, to identify areas to shore up boundaries, and to track progress. All right, but what about gems and engines? Note that this workflow is very different from when using inline gems and engines to modularize your application. To compare and contrast these, Packwork supports gradual modularity. The process of extracting large areas of existing systems as a gem or an engine often forces you to solve modularization problems in areas of potentially low business value. Whereas Packwork permits aspirational gradual modularization by permitting you to state an idealized system diagram, and then it gives you a to-do list to get you there. To put it another way, Packwork decouples statements about system structure and boundaries and the implementation of those boundaries. Packwork also makes it inexpensive and simple to change boundaries, as creating packs and moving files between them does not have to affect your runtime at all. This also makes it great for greenfield projects where you may be learning more about the domain and the boundaries along the way. Since we're talking about inline gems and engines, we don't need distribution or versioning, but Packwork doesn't support those today. And test speeds are pretty comparable when we use Spring and Bootsnap. Gems are nice because they support strict boundaries. A package with no violations can easily be a gem. And to that end, we released another gem called Package Protections to ensure that the boundaries of packages can remain as clean as a gem or an engine. Lastly, Stimpack allows packages to have some engine features with less boilerplate. All in all, we still strongly believe that gems and engines are and will continue to be a critical component in the modularization toolchain. And we've also found areas where even though a part of the system could be a gem, at Gusto we're perfectly happy if it decides to stay a package indefinitely. So I could spend a lot of time comparing and contrasting gems and engines to Packwork packages, but for now I'll charge ahead. And if you have more questions, please share them with me after the talk. So a system never starts off as a big Rails application. It grows into one organically. The practices that have led to your success at one scale may create confusion and stiffness at another scale. Likewise, tools that are intended to serve a big Rails application may not be appropriate for a small Rails app. Therefore, big Rails tools must be able to be adopted gradually. Scaling a big Rails app has technical components, but it can't be achieved without addressing the behavioral and cultural components. We can't just turn on these technologies and expect to achieve the next level of growth. It requires a ton of evangelization and education. Every step of the way through this transformation, I was working with teams to ensure the desired outcome was being achieved. My first goal here was to get every team to turn on privacy and dependency enforcement, which basically means that CI will fail if Packwork detects a system boundary violation. To do this, I first needed to know who to talk to. I reached out to individuals with high context and pushed them to add team owners to packages. Over the course of about a year, almost all of our packages are now owned by a single team. In some cases, accomplishing this meant developers had to reorganize their code, so to decouple domain areas owned by different teams. Concurrently, I met with the teams that own packages and then gave them basically the same spiel that I'm giving you now about why I think this stuff is so important. One by one, teams committed to create a boundary between their public and private API and to manage their dependencies explicitly. So this all turned out pretty good. You can see that standard S-shaped technology adoption curve starting in October when we began to collect this data. As expected, teams adopted these tools at different rates and with different energies. But overall, there was general consensus about the value of this. However, I found too often teams were simply updating those violation to-do lists as if that was the one true way to resolve a failing Packwork build step. It's kind of like adding Rubocop to your application, but every time there's a Rubocop error, a user just adds to the Rubocop to-do list. And while linting is somewhat straightforward for people, Packwork pushes us to create public APIs and be thoughtful about our dependencies. So it's much harder to get people to use this tool effectively compared to a linter. This all created a need to rethink our feedback loops. When it comes to a big Rails system, or really any software system, here are some events we care about where we want to improve our feedback loops. Note that we could add countless more events here. These are just some events that we know basically always happen and for which we already have a platform to build on top of. I mentioned that challenge that I was now facing, that a lot of the time users were just running that command to update the Packwork to-do list. In order to understand why users were doing this, I needed to dig in. Digging in was all about doing something that doesn't scale to figure out how to make it scale. To do this, I set up a Slack integration to let me know anytime there was a new privacy or dependency violation. I would then comment on the PR, asking the user to share more info. I created a spreadsheet tracking each PR where I left comments, and over the course of about a year and about 1,000 pull requests, I learned a ton. I used the spreadsheet to create histograms of why people were updating the to-do list, and use this to improve documentation and better understand how to support these developers. More importantly, I frequently met with developers over Zoom to share more about what we're doing and why. In doing this, developers began to become more familiar with the system, and a cultural shift began to take place. Developers understood that there were reasons why we were doing this, and that there were real people on the other side that cared about how developers looked at these messages and used these tools. Over time, I noticed developers began to proactively add context about these violations. And frequently, oops, we're back, all right. And frequently, they would address the system design concerns before I even got a chance to leave a comment. Based on developer feedback, as well as to improve the efficacy of these feedback loops, we built up some tooling. Early user response informed us that developers wanted a faster feedback loop. So we created a VS Code extension for Packwork and added the CI check as a configurable Git commit hook. To improve other feedback loops, we created systems to automatically leave helpful inline comments on PRs where Packwork detects a privacy or dependency violation, as well as when the developer adds to the to-do list. So this graph shows the number of packwork violations on average for each file over the past year or so. All said, we can see a clear downward trend. And about that system graph from before, well, we still have a lot of work to do. So what's next? Just as Rails itself is the product of an engaged and passionate community, I hope that we can take the same approach with big Rails applications. There's so many organizations who are currently or will soon be facing the challenges of managing enormous domain complexity. I'm so grateful for all of the contributions from the individuals and companies who have helped be part of the solution. Some of the questions that I have for the community are, in what ways can Ruby and Rails continue to offer great tools and cultural norms that help users create well-modularized systems? What can the different conventions of packwork packages, gem specs, and other packaging systems learn from each other? So all of these tools that we have released, along with the tools that the broader community has released, are, like us all, imperfect. If you're interested in this problem space, come join us at Gusto or at any of these other communities. Everyone is welcome. You can also catch me right here after the talk to chat more about this or to pair, or just shoot me an email. Your feedback on all this would be greatly appreciated. Whether that be trying out the tools and shooting me a message about your experience, leaving comments, opening a pull request, or experimenting with different approaches, everything is welcome. I hope that I've been able to share some of the value that we've extracted from these tools and approaches, and I'm excited to work together to try to solve some of these problems. Thank you.